Hello and welcome back. And well, it took me a few days to get to this point. We're here to talk about Bison and Flex and C++. And to be honest, of all of the videos I plan on recording, this one is the one I dread the most. Because quite frankly, it's the most difficult. I've put probably 10, 12 hours into preparing for this video. Because quite frankly, Bison and Flex, to get them to work together with C++ in the modern way, is crazy complex, and it's not that well documented, in my opinion, anywhere that I've found. Most of the videos or documentation that people write on it are talking about the old way of doing it, the C way, and yeah, it's it's difficult. Having said that, like I said, I've already written my language here twice, and we're doing it a third time, a new way. And each time I've had to spend time at the beginning trying to figure out how everything is wired together. And yeah, it's difficult. So we're going to jump in. But first, let's talk about a few changes that I made from last time. I don't believe that I have this open, so let me just pull over a window. There we go. The GitHub repo is live. And if you look under the tags, you can, for example, go to episode 2, and that is the state of the code at the end of episode 2. And you can see from my perspective, it was 4 days ago when I made these commits and pushed them in, the last one in. And of course, at the end of today, it'll be episode 3. But anyway, just wanted to point out that yes, it is there. But what I've started doing is started making changes and enhancements. I'm not going to do everything on camera. Sometimes documentation changes and other things, but I want to at least show you what I'm doing so you kind of see why I might approach something in the way I am, or so you can see the effects of what I'm doing in terms of, what do the documentation changes do. So let's see a couple things. First, I did change my my bash prompt so that it takes up less room, and I'm having my you need to have this set so that you can see what I'm talking about, so that it just shows my current directory and which branch I'm on. In this case, I'm on the master branch. And then let's see. Hello. There we go. It wasn't behaving there. I have some changes. And let's just look at a few of them. First of all, in the doxy file. Now, this is, again, the doxy file are all the configurations that when you run Doxygen to automatically generate your documentation, this is the file it uses for all those configurations. So let's see what I did. So I'm just going to say git diff and then doxy file, and this will show me the additions. And let's see, I've only done a couple things. The first one, it says the project name, I changed it from being Tang, a template language, to just Tang by itself. Okay, that's fine. And then example path, I added a dot. And well, what does this mean? Well, I'm about to show you how I did this, but I added, in one of the documentation pages, I say, hey, just include the license. And it needed to know, Doxygen needed to know, Doxygen needed to know, where do I look for these files? And so I'm telling it, look in the current directory. Okay, so that's the difference in the Doxygen files. What else? So what did I change in license? Let's see. I changed my name just from my username to my actual name. The username was set up by Git when I initiated it. The README is different. So let's check that out. Git diff README, and there's a lot of stuff. Before, what's in red here, Tang is a new template language library. Well, now there's a lot of parts to it, and this isn't written in Markdown, and I have what I hope are examples of what the goal of the language is, and I won't know if this works until we push it to GitHub. And I have a few more pieces of information about things that you can install, packages that you can install in order to get a better development experience. And in fact, I'm going to point out a few of those right now. Number one is Doxygen will also generate a PDF of our documentation, which is actually kind of cool, and I'll show you that in just a moment. But in order to do that, you also have to do these two repositories, the Tech Live LaTeX base and Tech Live LaTeX extra. And so you'll want to install those. And then the last one is iNotify-tools. And then, you know what, well, this one, the last one I'm going to tell you is not part of the installation, but you know what, I'll just go ahead and add it to this. So I'm going to the README Markdown. I don't know where this is going to be for others for the compiling. There we go. And I'm going to say for the last one is going to be, I've got a moth flying around. It's late at night here. If you're working in the WSL, Windows Subsystem for Linux, you can install the WSL. What is its name? I can use this other window here. Let's, it would be sudo apt install WSL, and then it's the U. WSLU package. There we go. And there we go. We'll just say sudo apt install WSLU. There we go. And then an example use might be WSL, I think it's view. Let's see, WSL view, yeah. And then dot slash, what is it, docs slash HTML slash index. Yeah, that's basically what I want. And since I'm typing this in, I should probably show you what it does. And right now, if I run this command over here, this WSL view, it basically tells Windows to open up that file in whatever program it's supposed to open up with, almost as if you had double clicked it. So when I run it, it's a website index, and this is the documentation page, right? So we can look around, and that's when we say, before it was called Tang, a template language documentation, and we'll see how it changes in just a moment. So, okay, so that's what changed in the README. Git status. Oh, so in the Tang base, let's see that. Git diff include /Tang base. And I added a block of text here that says on the main page, that's going to be its title, Tang, a template language, and create a section that's a quick description and all this. And that may be, no, and I added more information about the base class. Okay, so yeah, that's good. Can't quit out of the command line. All right, and let's see, the change to the make file, I'll show that in just a second. So for right now, I'm going to say make doc make help. Oh, it's docs, plural. So make docs, there we go. And now I'm going to refresh this page and you'll see the changes that have been applied. There we go. Tang, a template. Now, the easiest way for me to undo this is to get status. You'll see that there's a lot of changes in the docs file. Okay, fine. Is to just rm-rf docs, never do this, and then get checkout docs, and now it will completely reset that. And so now when I refresh this, you'll see before it was Tang, a template language documentation. Why? Because I didn't have a title for it, so it gave it that title. And it added the word documentation. It looks weird, and then it put Tang, a template language, up here, and I don't want a template language up there. So, and notice the page here is empty. If we look at the classes, say the Tang base itself, there's not much here. Okay, but now let's rerun the make docs command. Refresh, we see that our title is very simple. We no longer have that weird extra word here. We've got the quick description. It links to the YouTube playlist, the GitHub repo, talks about the features. Here's where I was saying including the license. So it just includes the license file there. And now these are, you know, if this were a long page, this would jump down to that place in the page. And now let's go into the classes, the class list, Tang base, and we'll see where there's a better description. And this will just grow as we add more description things to it. So, okay. So I like that. So get status. What else? Now there's a lot of changes in docs, and we're going to add all of those in. We talked about what's in the doxy file, what's in the license. Let me clean this up. So I'm going to say git add doxy file license. Don't want to do the make file yet because I want to address that readme. And then everything in docs. I'm good with that. Oh, and Tang base, yes. Okay, now I'm going to commit this and just say and what else was there? Oh, there's a license. No, that's fine. Improving documentation, that's fine. And now, what did I change in the make file? In the make file, here we have, first of all, I've got this sort. Okay, so the .phony, I added something docs-pdf. So I added a rule for docs-pdf, and this will generate the the PDF documentation, first you have to make the normal documentation, and then you go into the LaTeX directory and just, there's a make file in there, and so this will do that for you. So if I can demonstrate that, we will make help. It's called docs-pdf, so make docs-pdf. There we go. And now if I WSL view, where did I say this is? Docs, LaTeX, and refman.pdf. This is the default name, but oh well. That opens up and we can see, oh, because I was looking at it earlier, so it scrolled down to the bottom. But this is the documentation PDF that gets generated. And you've got your table of contents. You can jump around. You see everything, right? The links to the YouTube, links to GitHub, the features, the license, the class information, of course. I can click on it and it will take me directly to that page. And again, this is just, it generates a nice PDF. So, okay, great. Now we made a make rule for this. And what I'm going to try to do is update the documentation after each episode, right? And then always commit that so that it will be in the repo as well. So if I go to get status, there's stuff in the docs file. So git add docs, and I know that there's changes in the make file, but I'm not going to do that yet. Let's see, git commit -m, and this is going to be add PDF. Sure. Oh yes, and I could not stand it being called main. I've been using Git for 15 years through the command line, and the master branch always been called master, so I renamed it to master. All right, so what else do we have here? Just making sure move everything back around. There we go. All right, what else do we do? Git diff. Oh yes, so in the make file, I'm going to expand this out again anyway. I wrote a little, and this is why you need the iNotify package installed, because, and this, it didn't work that well on earlier stuff in WSL2, but it's working now. But you can use iNotify wait, and I'm telling it which directories to watch, and basically whenever there's a change to that file, it will automatically recompile everything. So that's what it does. When I say watch, make watch, it will make the all command, which compiles everything, or updates it if it needs to, and then just says, hey, I'm waiting for a change. And when it sees a change, then it will loop through again, and it's just going to do that forever until you Control-C out of it. So what does this look like? Make watch, and iNotify wait is not found. Evidently, did I not install it? To apt install iNotify tools. I guess I had not installed it on this one. Okay. Make watch. There we go. Now it's waiting for a change. And if I were to do something such as it's one of the source files, and I don't even want to really want to change it. I'm just gonna, add something, delete it, and then say write that. You'll see that it recompiles it. That's what I want. And we can make it do other things. We can make it run it as well. But for right now, it's just going to recompile. And that's the goal. Okay. So now get status. Is that the only changes in the make file? Oh yes, for the help I just shortened how wide the help was away. It used to be 30 spaces, now it's 15. Okay, so git add makefile, git commit -m, and I'm going to say and docs-pdf command. All right, and now all right, what else have I done? So what's in Bison and Flex? Did I? Well, first of all, I'll show you dot files. So what is dot files? That's a horrible name. I should rename that. Instead of dot files, I'm just going to call it settings. Yeah, so if we go into settings, what you'll have here is, this is my vimrc file that I'm using. Let's edit it. This is just so that you have it, so that you can see. I tried to give credit where credit is due for changing things, but let's see. Right now you can see it doing relative numbering unless I start editing, in which case it actually gives me line numbers. Let's see. My tab stops using color slate. Okay. Stolen from here. This is just for I don't want tabs in here. I want spaces, but makefiles must have tabs. It's part of how makefile works. So this will say if I'm in a makefile, use tabs. If I'm not in a makefile, use spaces. Let's see. I've got some things about folding code so that I can move around files more quickly, and those are the commands there. So okay. And then also in your home, in your user directory, I have this, you have to put it in the .vim of your user directory, and then this file type .vim. And what is it? It is, there's a reference to where I found it, but basically I'm saying treat the Bison files syntax highlighting wise as if they're a C file, and the L files, the flex files, also as if they're a C file, just so I can get some syntax highlighting. It's not perfect, but oh well, it works. All right. I'm going to git add settings. Make sure I didn't add anything I didn't want to. That's good. Git commit, and our commit message is add sample vim settings. You don't have to use them, but they're there. All right. So now what's in Bison and Flex? If I go into Bison, there is I'm thinking this is something I was this is something I was playing around with, and I'm not starting with this anyway. It's I'm doing it in a completely different way now. And you'll see, by the way, since I made a change, it tried to recompile, but it said, oh, there's nothing that needs to be done. So it's fine. And then same thing for Tang scanner. I think, yeah, this is an old version, and I was going to use it as a starting point, but not going to do it that way. So, all right. So we're starting off on a clean slate. Now, here's the problem with Bison and Flex. First of all, the names are confusing, especially when you don't know exactly what they're doing or how they relate to one another, when you don't have a concept for it. So um, I'm going to, I'll reiterate as we go through as to what they're doing. But if you can go back to the previous lecture, but just remember, Flex is a lexer. An lexer just means it breaks up things. We also use the word tokenizes a string. So if I give it if I give Flex a long file, it will say, oh, here's an if statement, an if, or here is an open parentheses, or here's a number, or here's an equal sign, or something else. Oh, here's a variable name. And I tell it what to look for. But I could, it doesn't know how those relate to one another. It identifies those tokens, those lexemes, either word. And then Bison will say, hey, Flex, give me one of those. Give me the next one. Give me the next one. And it tries to find some sort of structure. And if it does find a structure, then the output of that is an abstract syntax tree. If it can't find a structure because somebody gave us maybe gibberish, then it will give us what's known as, of course, a syntax error. And so that's how they relate to one another. Bison finds the structure in all of the discrete parts that Flex identifies. The problem is they're wired together like a rat's nest, and they were written to be backwards compatible with software that was written multiple decades ago. And that's not necessarily a bad thing, but it also means that it was written using approaches that, quite frankly, if they were writing this software today for the first time, they would not take the approach that they did take. But we're stuck with it, unless you want to use different software. But I don't. I want to use actually Bison and Flex. So, all right, that means I have to spend hours figuring out how it works each time I do it. And then I set it up and I say, I'm never going to, but I didn't take notes before. This time I have a lot of notes, and I still am probably going to have a huge page of compile issues. But having said that, we're going to see if we can delve into this and figure out all of these parts. First, a little bit of bookkeeping. Bookkeeping, is that going to be the right word? I'm not sure. What I need to do is I need to set up a few classes. So first, we're going to make in our we'll do the include directory first, and I need a place where I can put an error message. Okay. Error.hpp. Why not? This will represent a syntax error or a runtime error later. I mean, it will hold the information that we need. Okay, so that's what we're doing. And for right now, this is the HPP file. So I'm going to call it nope, I need string. Location.hh doesn't exist yet, but it will be generated by Bison. So, okay. And location.hh, yes. And then it's going to be a class called, namespace Tang class error, and it doesn't I'm going to make a constructor without anything, and I'll worry about, do we want anyone to be able to find this? Yes. So that needs to be public. And then, no, I'll make them public as well. I want there to be a message and a location type location. All right. There we go. Do I need, you know what, let's, error.cpp. There we go. And I always debate on whether to do it this way or another way. No, I'm not going to do it this way. I'm going to say Tang error. So Tang is the namespace, error is the class name, and then the constructor name is error, doesn't take anything, and the message is just going to be empty. There we go. I think that's all I need there, and of course, the moment I get out of that, I'm gonna know that I missed something. All right, I also need something that's going to represent the abstract syntax tree. Okay, so include /ast.hpp. So abstract syntax tree, and yeah, we'll do that. So far, it's going to be very, very simple. Namespace Tang, class, and we're going to say AST node. All right. And do I want to give a constructor for this? I don't think so, but I will give a virtual destructor. And the reason is because I need polymorphism to kick in. And I may not need to do anything right now. In fact, I'm just going to define it here. And then AST node integer, because I said that I wanted our first example to recognize a 3, if nothing else. And AST node integer, and what does it need? Oh, wait. I need to say what it's inheriting from. Public AST node. There we go. Let's see. We need to be able to create one, so there must be a... What's the word? Constructor, yeah. AST node integer, and it needs to take 2 values. First of all, there is uint 64t. Probably need to include something for that, but I can't think of what it is off the top of my head. And that's going to be a number, and it also needs a location. I know we're in the namespace Tang, so I don't have to put location. Lock. Okay. Now, we're going to have this set as, let's see, AST node and pass it lock, and then my value is going to be the number that's passed in. Say so private, I've got a val or a uint 64, so a 64-bit integer that's, do I want it unsigned? No, I don't. I know I also just left off my semicolon. Okay, just a regular int. And because I didn't give this one a constructor, I need to do that AST node that takes location, lock, and it will store that in a place called location, lock. And what is location, you ask? It is private location. There we go. All right, so a couple things. What is it doing so far? You know what? Instead of having a virtual destructor, I'm going to declare a let's have something that returns a string and maybe call it inspect. Well, I can't have it do nothing, but that's fine. I will put it in the CPP file. And of course, we need to, this also needs to have that virtual I think that's where override goes. If it doesn't, someone will tell me, like the compiler in just a moment. All right, so I need all my Tang stuff. So I did inspect. So my constructors are just fine as they are. I need to provide the inspect for AST node and AST node integer. Sure, no, I can't quit yet. Can't let me do that. I've got to pound include string and pound include location.hh. Yep, that's right. Okay. Source/ast.cpp. Yes. There we go. And I said I wasn't going to do it that way. Tang, this is AST node. Inspect. And of course, what am I missing? The fact that it's a string. So in fact, I can probably watch it give me an error in just a moment. I'll have to come back and put them in. What do I need to do? So return nothing. That's fine. And then for string AST node integer inspect I don't remember how to convert an integer to a string. Is this right? Well, normally I like to put all of the default ones. Let's see, IO stream, and I think it's just going to be return to string. What did I say it was going to be? Val. I'm going to standardize on. All right. If this doesn't compile, I'll find out soon enough. But I can't do anything until I get that location.hh. I can't test it. So that means, but I can't do the Bison one. Well, no, I can make it generate. Okay. So yes, I'm arguing with myself. So I've got two things. I've got an error object that I can hold an error, and I've got an abstract syntax tree node. All right. That's the goal. Now, let's look at Bison. Okay, I have a directory here called Bison, and my goal is to put my Bison files there. We may need more than one. Who knows? So what's the name of it going to be? Bison, and this is going to be, I'm going to call this Tang parser because there may be other. This is the parser for the Tang language itself. So tangparser.cpp. That's good. No, not .cpp. This is a Bison file, and they have a .y extension. Why? Because a little bit of history. The original project was called YACC. YACC, yet another compiler, and then this was kind of I don't know if it was written by I don't even know if it was written by the same person, but it was meant to succeed it, so to speak. And so even though the original one was yet another compiler, YACC, it's pronounced yak, like the animal, YAK. And so programmers think they're hilarious, and so this one gets the name Bison, but it still uses the yak extension. So what all is going to go in here? I'm glad you asked, because there's a lot, and I'm just going to have to start looking. So first of all, do I want to do it this way? I'm checking some of my notes. I've got cheat sheets. I'm not copying, but first of all, which version of Bison do I have? Bison-V, maybe capital V. There we go. I'm on 3.8.2. So I'm just going to say %require 3.8.2. There we go. Next, the skeleton is what should Bison use, because all that Bison is going to do, it's not going to compile anything. Rather, it's going to generate source code for us based on the settings that we put in here. Okay? And so there are different types of parsers, and the one that we're going to use is the, I think it's look ahead, look right one. I believe that's what it stands for. It's been a while since I've read up on these. Basically, there's different. Remember, Bison is trying to find structure in the tokens that Flex is going to give it. So it can say, well, what's the next token going to be, and it can make a decision based on that. So it's very efficient at what it does. It means that sometimes we have to do a little bit of work in our language definition for what those patterns are, but we'll get there. Okay, so this next one is defines. Kind of weird, but I think that is, let's see, I had that somewhere. Defines, oh yeah, it says to create the .h file with all the definitions that we need. Okay, great. Keep going. Oh, I said pound defines. You can tell what I type all the time. It's percent. It is percent defines. I've abandoned my Vim key stuff, so I need to get back to it. Pound define the API.namespace, and this is our namespace. So Tang. There we go. You don't have to put the spaces in there, but I am for readability. Pound define the API.parser.class. That is, so the parser is the flex or the lexer, and we're going to call it Tang parser. Just that's what it's going to be looking for. Like I said, these wire together pretty crazily. You'll see in a moment. So API.value.type variant, before it, if you don't do variant, then it has to do all sorts of weird pointer manipulations and everything, as opposed to using the C++ variants. So this is pretty nice. The API.token.constructor. What does that do? I had a note on that. Yeah, it defines something called symbol type, and we will use that as a return type for some of our stuff. So you'll see that show up later. Parse.assert, it adds some asserts, and we might be able to take that out, but I believe it's better for it's runtime assertions, just to make sure everything's being created and destroyed correctly. Parse.trace is for better debugging. The define parse.error verbose is to get better error messages. Percent locations, that tells it create the locations.hh file. All right, the lexer parameter. This is what it's looking for. Do I have a better? Yeah, it's arguments that YYLex should accept. What is YYLex? There's a lot of YY things in this. For Bison uses YY to prefix a lot of its stuff. But what we're saying is that it needs to be of the namespace Tang, and then Tang scanner. A scanner, yes. So pass in the scanner by reference. And then parse param. And let's see if I can. just because there's 3 of them. So what is this? This is going to be, the parse param is, there's going to be a Tang scanner. And this is when we call Bison, it's going to be wanting these 3 things that we're giving it. And we're going to give it a pointer reference to our AST. And then lastly, info again, and this will be a pointer reference. And I'm calling, it's not error info. I did that in a different incarnation of this where I'm looking through notes. So we're going to define prefix. This is there's an enumeration that it uses, and what prefix do we want to use in those enumerations so that it doesn't have conflicts. I'm just going to say Tang parser, and let's see. Now there's a couple tokens that we're going to define, and this for right now, just trust me that we're going to be using them. One is the end of file, and we're just giving it a value of 0 because it will assign a number to all of the tokens. I just like having the EOF as 0, and then we give it a user-friendly thing. So I'm going to say end of code. Why? Because it could represent a template or it could represent a script. So, but anyway, end of code. And another one is going to be of the type int64t. We talked about that earlier. Integer. And so why are we putting these things in quotes? It may say, was expecting an integer because we just said integer, but found end of code instead. So it goes into the error messages that we can generate. All right, now we've got types, and these are, if you've studied formal grammars at all, these are the non-terminals, but basically these are patterns. And one's going to be called program, and the other one is expression. There we go. All right, now just to get all that. So what we're doing is, again, we're setting up, we're telling it what parts are going to be in our language and the patterns that we're using. So now we have to tell Bison what file, what's going to be in the header files. Okay, so we do that by this %code, and requires, this is going to be code that is put in the .hpp file. Yes, so we're going to standard int.h, yeah, so that's why I can use the int64t if memory serves. Pound include ast.hpp. Did I just call that error.hpp or error info? Error. Okay. There we go. And lastly, in the Tang namespace, I'm just warning it that you will see a class called Tang scanner, but that's all I'm giving it. All right. And you know what? No, I think the pound includes have to be left aligned anyway. I just don't like having this double thing, but Oh well. Now, %code and top is going to be at the top of the CPP file, but not in the HPP file. So we're going to pound include the scanner.hpp, pound include the parser, and location. Do we have to include location? It might be included already. It shouldn't hurt to include it this time. And then lastly, there is a function that we need to declare, but it's declared static so that it doesn't conflict with other namespaces. But let's see. It's going to return something from the namespace Tang parser, which is what this is generating, and it is the type is symbol underscore type. And this is something that will be generated because up here, what did we, I think it was the API token constructor that says, hey, create this symbol type. It's like, why is this not moving? Because I'm hitting the wrong, there we go. Symbol type. And so the name of the function is yylex. Now notice this is a bare function. It is not namespaced to anything, and it it's not namespaced to anything, and it's not part of a class or anything like that. It's just the function yylex. And if we were to just compile this without the word static, then anywhere that we use this object file would have this yylex function in it, and it could conflict if we have another file that also has yylex. So that's the reason that we declare it static, so that it does not conflict with any other files. Okay, yylex. And what does it take in? It takes in a scanner. All right, and all that it does is returns the scanner's method get next token. All right, so it seems rather simple, but let me just very, very briefly describe what this is. So Bison is going to call the yylex function internally to get the next token. And it will give us the scanner because we told it to up here in the lex parameter, right? We said this is what we want you to give us, right? Anyway, and so I believe that's where it relates to. But anyway, so it's going to give us this scanner, and our job is to return something of the type of symbol type. So we call the scanners, which we haven't written the flex part yet, but this is from flex, its function called getNextToken. And that's what I'm saying. These are kind of wired together in a lot of different ways. So, all right, now that we've done that, we get to actually start our grammar. Now, the problem with grammars is that I've taught, theory of computing stuff, and lectures over grammars are, big full lectures. And well, I guess this recording has been going on for a little while, but I'm not giving you the entire lecture. But basically, a grammar is it's like a substitution. It's like a Mad Lib, so to speak. If you've heard of that, to say, I like adjective, noun for supper, whatever. And somebody says, oh, here's an adjective, and here's a noun, and you put them together, and haha, it's funny. And except that it's recursive, you can do that. It would be like and we do this, by the way, when we speak our own language. In the case of English, we have the subject verb order. I go to the store, or to the store is a prepositional phrase where to is a preposition. Store, is that the object of the preposition? I don't even remember anymore. But anyway, it's been a very long time since I've done that. That's what it is. It's patterns. So in this case, we're going to say the base of our, so I'm typing now, the base of our grammar of our pattern, the start substitution is, we're going to call this a program. Okay? That's just, it helps us mentally. And now we get a double percent. What's the double percent for? It's a divider for Bison to say, okay, now we're into the grammar part. I told Bison that we're going to, a program is what we're starting out with, but what is a program? How does it, become other things? What can be substituted in? So this is going to be extremely simple, but we'll do it here. So first of all, a program can be, and I'll put it here, it can be an expression. Okay? And I'm not filling this out all the way yet. In fact, I'm just going to leave this here and I'll come back to it. Or it can be the end of file. Okay, if it's an end of file, again, I'm not going to do anything, and then nothing. Now, as for the spacings I'm using, this is just something that I've used because, trust me, when the grammar gets bigger, it makes it readable. But for right now, okay, so what's an expression? An expression can be an integer. Now later we'll add other things. It could be a float. It could be a string. It could be something plus something. But for right now, an expression is an integer. And if an expression is an integer, what do we need to do? So the idea is, if flex gives us, if it says, hey, here's an integer, I need to turn that into something. And the answer is I need to turn it into a node in the abstract syntax tree. So this is going to be weird, but it's represented by a double dollar sign. Because remember, these are just patterns that Bison is going to take and generate actual code with. So the double dollar sign says this is what I want integer to actually represent. So it's going to be a new, because I'm dealing with pointers. I said that these are pointers. In fact, it's right there. Ultimately, a program is a pointer to an AST node. And ultimately, an expression is a pointer to an AST node. Well, an integer is actually an int64. We can see all these, again, are at the top, right? An integer is an int64. So this, if I refer to $1, because that's the first thing that's here, later you'll see that there could be multiple, but for right now, $1 refers to an int64. Okay? So I want to create a new AST node integer. All right. And you remember this constructor that I created, it needs a number and it needs a location. Well, again, Bison's doing some magic for us to say if $1 is the value, the @1 is the location of that value. So there we go. In fact, yes, that is what's going to happen. So when Flex says, here is an integer token, and yes, it attaches the value to it, which is an int64, then this pattern says integer now is going to be represented by this AST node, and we're using new to create it. Yes, we'll have to worry about cleaning up after it later, but for right now, we're just doing this. And now, so that means this expression is a pointer to an AST node, right? So that means this right here, expression, is a pointer to an AST node, and I need to pass that up to program. So I do that by same double dollar sign is equal to, and I'm just going to say $1. Why? Because it's just going up. And in fact, I'm not even going to say program is that. I'm going to say that the AST that got passed in, right? There's those three things that are being passed in. There is the scanner, the pointer to the AST node, and the error thing. Okay, in this case, AST is going to be a 1. Or is going to be that expression. So that's how we pass it out. Okay. Again, weird. It will make more sense down the road, but for right now, we're just trying to get a starting place set up. So, okay. A double % to say I'm done with my grammar. And that grammar is going to grow significantly as we add, something plus something and something divided by something or something less than something. Function definitions, Anyway, okay. The last thing that we need to do, and this is code that's going to be at the very end, is we have to define our own error function. And it doesn't return anything, so void, but it's in the Tang namespace. It's for the Tang parser. Remember the parser's what Bison is generating. And error. And let's see. Location. I didn't have to do standard string, but for right now, I'm leaving it empty. But what we'll do is we will actually, this will turn into our syntax error. This will be, hey, I can't find, whatever. It will fill out the message. I was expecting this and I found this instead. Or I was expecting this, this, or this and found this instead. If you had, A is equal to 3 plus and then a semicolon. It would say, I'm looking for an expression but found semicolon. Yeah. Okay. So the last thing is to write that thing. All right. Now Bison has a command, and if we go into Bison, there we go. I have notes. What would this look like? Let's do Bison-v. The output's going to be Tang parser.cpp. And let's see, I don't remember what all those options are. I'm going to have to look it up. What did it, unexpected end of file. So what did I mess up on? Oh, I needed another closing semicolon. There we go. Great, no errors. And now let's look and see what's here. So it created location.hh. It created a Tang parser.cpp and .hpp, and I don't care about the .output, and the .swap is because I'm editing with Vim. But anyway. Oh yeah, I think I added that as a commit later, and I don't remember if I talked about it, but so that Git will ignore the .swap files. But anyway, okay. Yeah, that's good. But I don't want this to be done here. That is, I mean, I don't want the generated files to go here. So we're going to create a makefile for this, to do this, but to put it in the generated directory. But for right now, okay, I'm going to remove location.hh and then star.cpp, star.hpp, star.output. There we go. Okay, so at least I have my .y file left. Okay, great. So there's Bison. And believe it or not, this is going to do everything we need from Bison. There's 2 more things that we need to do. You say well, two more, and then work on the make file to get it all to compile correctly. But let's do the flex one. So flex, and we will call this the Tang scanner. And flex is based off of the program Lex, which is Lexer, right? And finding lexemes. But it's supposed, I think it's fast Lexer is what flex stands for, but it still uses the .l file extension. So let's see what this is, shall we? This one will also be really big later, but not right at the moment. The problem is Flex was not designed for... The word that you'll hear over and over is being re-entrant. And what does that mean? Well, it thread safe, if you know that term. But another one is, it's the idea of if you have one program running in one context, in one thread, and another one running in another thread, and they are both accessing the same library at the same time, they should not interfere with one another. That's when it's re-entrant. That means you can go into it and you could go into it again in a different context and it doesn't affect one another. The problem is the Flex source code was not, or the stuff that Flex generates was not designed to be that way. It used, global variables, and that was perfectly fine for the software that it was being written for way back then. Well, so now they've had to kind of bodge it together, and to generate classes that don't conflict with one another. It's messy. Okay, so here is what we're going to do. So the first thing is it uses percents, and let's see, we need to tell it that word option is we're doing generate a C++ scanner class. In fact, I think I want to... Yeah, we'll do it like this. All right, the next option is the YY class. Okay, what is YY class? This is the ultimate class name that we want to use. Okay? And I want that to be Tang scanner. Why do I say ultimate? Because remember, there's a little bit of trickery that's having to go on. So Flex will create, it has a base class called Flex Lexer. All right? And it wants to create a derivative class, a child class for us, right? Object-oriented stuff, inheritance, and all that other stuff. It wants to create one for us, but the problem is we need it to be even more powerful. Whoops, hit my mic. We need it to be even more powerful than the one it's going to generate for us. So this is kind of like the last one that we're going to do, but there's going to be an intermediate one as well. And you'll see it. You'll see how it comes together. And so option prefix, in this case, this is going to be the prefix used to generate the intermediate class. And I'm just going to call it Tang Tang. Why? Because Tang is the namespace, and then this is the Tang scanner. Later, we may have something to deal with percent encodings, which would be handy if we need to deal with URL encodings, which use percent encodings. And we need to scan that, so it would probably be called Tang percent. Anyway, that's the idea. Okay. The option prefix that deals with the intermediate class. Okay, option no YY wrap. Remember I said there's a lot of YY stuff. I'm telling it, this says don't generate the YY wrap thing. What is YY wrap? It is for if you want to be able to scan one file, and then when it gets done, it doesn't immediately stop. It uses YY-wrap and says, hey, do you want to scan another file? So think of how like the compiler may do for parsing, the C++ compiler will parse one.h file and another and then another and another, and then I'm just saying it's possible. We don't need that. We're turning it off. It's just additional complexity. No default. What is no default? Well, this is to say I don't want any default rules. In other words, in all of the rules that I define for identifying tokens, I want to make sure that I specifically dealt with every possible case. And by me saying no default, Flex will let me know if it cannot meet, if I left out something. Or it will warn me, said, hey, you said no default, but the default can be reached, so you've got a problem. Let's see, option never interactive, because I'm not doing anything interactive on here. Like I'm not doing a REPL or anything like that. Option stack. Why do we need a stack? Well, because we're going to be going in and out of different modes. Think about we'll be parsing a template, and then it'll say go into script mode, and now go out of script mode and everything. And so the stack infrastructure lets us do that easily. So that's what we're going to use. All right. Now, what about code to put at the top of the file? So let's see. We've got a pound include for C standard lib, just for stuff that's coming up later. A pound include for our Tang scanner.hpp, and we're going to have to create that file. Another pound include for Tang parser.hpp. This was created by Bison. And our pound include for location.hh, also created by Bison. And this is not in a .hpp file, so I'm going to say using namespace standard. And now we've got a couple of defines. Now, YY terminate, there we go, is a macro. Okay? It's a macro that will be called when something goes, when we run out of the file. So what we do is, I'm just going to define it as return Tang parser. So this is something generated by Bison, the Tang parser, right? Make underscore, and you'll see this a lot. Make underscore something. And if I look at the Tang parser.y file, I'm going to remind you that we said these tokens, EOF is one and integer is one. Well, make underscore EOF. So it generates these for us based on what tokens we say. And an end of file will be given a location, and we'll pass in the location. Make sure I've got all that. No semicolon at the end, because the semicolon will be put in later. That's the first thing. The next one. I'm going to copy and paste this one in. Just because it is so long. And watch it paste in horribly. That's not too bad. There we go. So YY user action is, again, a macro that's going to be executed. But it's like what's going to happen is that Flex will say, okay, you told me to look for all of these different tokens, an if statement, an else, a curly brace, a number, like an integer that we're about to do. When it finds one, the very first thing it's going to do is call YY user action. And what we're going to do is we're going to increase the location. So we had to keep track of the location. So it's saying, go forward one, and or the step, actually it replaces, because the location has a begin and an end, and the begin and end each have a row and a column, right? Because think of text, right? You could select from one place to another, and it could span multiple rows. So this will have a begin and end, and what it does is it makes the begin to be the old end. So it moves forward, and now we have to move the end forward. So we go through len g is, I don't know why it's leng, but that's right. But that's the length. Oh, length. The length of how much it matched, and then text is the C string of what it matched. So what we do is we go through each one, and if we find a new line, well, we make the column be 0, and then we go down to the next line. Otherwise, just increase the column. So these are lines, and columns are commands that increase the end, right? So step moves the beginning to the right place, and then we go through each character and say, do I need to increase the ending one? Or So that's what it's doing. And it's a macro, okay? And I'm sorry, it's ugly, and we don't have a choice. All right, and now we do our %close, and that puts us into the next section. What's the next section? Well, we are, like I said, we have, this has the idea of a stack, where we can say we're either parsing a template or parsing a script, or maybe we're in a comment, and so we say, okay, start a comment and then parse it using special instructions. And when we get to the end of it, okay, go back to whatever you were doing. That's using this stack. And so we have these stack states, and I'm going to use %x, which means exclusive. Don't throw anything together that I don't specifically say should work together. And which ones am I going to do? It gives us one called initial, but I'm creating one called script, and we'll see why. It has a double % to say, okay, now we're on to the next section. And now these are the rules for matching tokens. This is what you've been waiting for, right? And don't worry, we're almost done with this file. Say, finally, it's been a long enough video. I don't even know how long I've been recording for, but we're getting through this. All right, so if I'm in the, for right now, I'm just saying if I'm in the initial or script, that's what, and I shouldn't put a space there. It probably doesn't matter, but all of the rules in this are, if I'm in one of these two modes. And we start out in the initial mode. I'm just planning ahead. But for right now, and what I said we're going to look for, we're going to be looking for a number. Now, we use regular expressions here, okay? So if you don't know regular expressions, that's worthy of looking up. But for right now, I'm going to say a number is any digits 0 through 9. So I can do that. Any digits 0 through 9. And 1 or more times. Okay. Not everybody likes this definition. Because for some programming languages, if you start a number with a 0, other than the number 0 or 0 point something, which is a float, but if you start with a 0, like 06, you're maybe in a different base. And we could write our language to support that kind of thing. That if I see 0x and then anything from 0 to 9 or A through F, to interpret that as a hexadecimal, we could write that into the language. It'd be very easy. But for right now, we're just going for just plain numbers. All right, so then we open parentheses, close parentheses, because it's what do I do when I finally match this? And, well, we need to do an int64t for our number, and stir to long using YYText, because YYText, as I mentioned earlier, is it's the C string that's been matched. 0 base 10. There we go. And then last we return something. We're going to return Tang parser. Remember this, so this was generated by Bison. And we're going to make something. We're going to make an integer, just like we made the end of file earlier, but the integer, we gave it a type. We said it's going to be created using an int64t, which is what number is. So we give it number, and then we need to give it a location because we told it we wanted to use locations. So I think that's right. I think we'll find out. And I already had that, so there we go. Now, if I run this, let's go ahead and do our EOF. So if I get to the end of file, call YYTerminate, then YYTerminate macro, which just returns an EOF, end of file. And because of the way we described our program, if we get just an end of file by itself, then that means, well, it's a valid program. We're saying we can match that. Just an end of file, which, I mean, a script that has nothing in it should output nothing, but it shouldn't give an error. All right. Now, at this point, the last thing we need to do is give 2% signs, and we don't need to put any code there, but it's because there is another section where we could add more code, but we don't need to do that. And last, let's go into Flex, and we've got this Tang scanner.l, and now we want to run Flex, see what it generates. So Flex, its output is going to be Tang scanner.cpp, and what do we give it? We're giving it Tang scanner.l. If we run it inside an action, it's not inside an action. What did I do wrong? Oh, I didn't give a closing parentheses there. Unrecognized rule and fatal parse error. Unrecognized rule. What would the unrecognized rule be? And this is just me being on line 47. Read the error messages, Corey. Why is it telling me unrecognized role for that? That's just the closing, unless there's not supposed to be a space here. I don't think that would be the issue. That was the issue. Okay. Sure. Now notice it says -s option given, but default rule can be matched. That's because I said, don't let me match the default. And -s is the command line option for what we set up here was no default. Yes. Okay, so we have to provide default rules. And what might that be? One is going to be just any character. If I can match any character, don't do anything, as in it's unrecognized, and so just skip it. I could return an error, but I'm not worried about that at the moment. And then, but it doesn't match the new line, so we have to do that separately. So, no errors. And it created a Tang scanner.cpp. Now, again, we don't want it here, but we want it in the generated file folder. But again, just making sure it can work. Okay. So, and if we look at it, tangscanner.cpp, you'll see that there's a lot of stuff in here. I'm just gonna exit because it's big. So rm tangscanner.cpp. Good, we're back to where we should be. Now, the last thing that we have to do is, you may remember I said, so Flex has to do this weird thing. It has a base class called FlexLexer. It's going to create one for us that's kind of an intermediate called Tang FlexLexer, because we told it use the Tang prefix. And there's reasons for that. It again goes to, there are some files that it has to, some, not files, that's not the right word. Some identifiers that functions, I think, that it has to create, and it needs to not conflict. Just like we had the issue in Bison where we declared something static. Well, in this case, we're having to solve it another way. It's kind of one of the reasons this is such a difficult thing. So, okay, so let's just jump into it. And this is going to be in the includes, and we're going to call this Tang scanner.hpp. All right. It's a brand new file, and we haven't been doing this, but I'm going to have to start, and that is, if not, define Tang scanner HPP. And then at the bottom, this will keep it from being executed more than once. You say, well, why don't you just use pragma once? I have reasons. But there's another one, and this is, I'm trying to find a better way of doing this, but for right now, I'm having to check for this. Yeah. Okay. So in here, what we do is we have to pound undefined YY flex lexer. Now, what is YY flex lexer? It is a placeholder name. It's something that's been pound defined. It's a macro. That is the name of our intermediate class. But it could be other things. So we have to define it as, what we told it. Prefix tang, and then it does the suffix of FlexLexer. It does that. So this is the name of our intermediate class. And YY FlexLexer is now this Tang FlexLexer. It's the name of the intermediate class. And now we pound include FlexLexer.h. Okay, and this, so FlexLexer.h is written so that you can do this. You're supposed to pound define YY FlexLexer, and then it uses it in the .h file to generate these intermediate classes. Okay, it's weird. You haven't seen that before, but it works. Now we've got another one. We need to undefine YY underscore decal. Again, this is a macro. That's it. I'm not going to say it's the prototype, but it is the function signature that is being used. And it's really weird. Basically, the Tang scanner.cpp file. We don't create that. Flex creates it. We're creating its .hpp file. But the .cpp file defines YYDecl to be something, and then it includes our .hpp file. It includes our header file. And we're going to say, no, 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 I didn't like what you declared it as. I'm going to declare it as my own thing. Why? Because, again, this is a function declaration, and the function doesn't declare the right type. By default, YYDecl returns an integer, and we want it to return one of these Bison tokens. So this is how we do it. We undefine YYDecl, and now we pound define YYDecl to be, here we go, Tang parser, symbol type. Okay, so that's the type that it's returning, it's a Bison symbol type. And then the function's name is Tang scanner. That's the .hpp that we've been doing. Get next token. All right. Now we're to actual code. A pound include, and again, this is our .h file, so iostream because we will need it. Pound include Tang parser.hpp, and this is where things, by the way, start getting hairy, because this includes this is including Tang parser, the Bison.hpp, but the Bison one wants to include this one, which is why we need the guards, the if not defined Tang scanner HPP. Anyway. And you have to do everything in the exact right order, or like I said, in just a moment, we're probably going to get some really big compile errors. So namespace Tang, and here it is, our class called Tang Scanner, finally. And it is going to inherit publicly from YY Flex Lexer, which is the intermediate class that Bison created, and public. I'm going to copy this next line because it's long. All right. Please forgive me. This is a constructor, which we will need in just a moment, that be consistent with my spacing, Corey. It takes in an I stream and an O stream, and all it does is it passes it to the constructor of the intermediate class, and that's it. Okay. And then we've got this is again the Bison symbol class. That is the token types, right, that we're defining. And get next token, which we define in another file that it basically calls the scanner, right? And now let's see, we've got our private stuff, and all that it is a location. Yes. Now this is, there we go, better indenting. End of a class, need a semicolon. That is the #1 mistake I make in writing C++. I always forget to put the semicolon at the end of a class declaration. Always. Or a struct declaration. Always, always, always. Okay. That's what we need. Those are the parts. We don't even have a CPP file with a main in it to run these. We can do that in a moment. But first, okay, let's get our make file working. So, okay, the make file. The make file. Okay. Gonna I don't want to do something stupid, so give me just a moment. So first we're going to do the Bison. Oh wait, was that no? Generated files. Okay. So what is this going to look like? So we've got this, the gen directory, right? Slash tangparser.hpp. Okay, we want that to be generated. And how, or what does it rely on, or what does it need to, if something changes, it needs to be regenerated, and that is Bison slash tangparser.y. So Bison slash tangparser.y is edited, it will regenerate the .hpp file in the gen directory. Okay, good. There, just copying. Let's see. All right, and I don't think I need all these make dirs. I think I had another solution for that. But this is not how we do it. We're going to do this with, I need a tab, Bison-V, which is what we did earlier. Gender tangparser.cpp-d, and then the first the $sign less than refers to this one. There we go. Okay, so that should work. Now we kind of need the same thing. Can I Y7? There we go. So flex generated, and this one is going to be scanner, but it is CPP, right? And this is flex, and this is scanner.l. Okay. Generating flex tang scanner. Okay. And now let's see. Oh, this one's easy. Flex, the output is the name of the target. Is that right? Yes. And the input is the first. There we go. Okay. Now, but that's not the only objects. Okay. So we have a special case rule. And this is just to make everything work right. And this is going to be our gender Tang scanner.hpp relies on generate directory slash Tang scanner.cpp. And this is so that as we do things that change one or the other, it trickles down to everything else. But that doesn't make sense. It made sense in my head. Basically, because the way Bison, remember, Bison generates CPP and HPP files, but Flex only generates a CPP file, and but we're going to yeah, this is right. So basically, if we change the Bison Tang parser.y, it will cause the Tang parser.hpp and location.hh to be generated. We need that. And that in turn will cause Flex to generate its scanner.cpp and scanner.hpp. And that will then cause our scanner object, which we're about to write the rule for, to be compiled. Okay? And that will then our shared library. Okay, good. So this links together the generating the scanner.cpp and HPP will cause our tpt.o to be updated. Yes. All right. So object files. We're going to... How many of these do we have? We've got one for the AST. One for the AST, one for the error, and one for our scanner. I think that's right. Okay, so let's do AST. That's based on AST. Is this, I don't think that's relying on this here. All right. AST.o. I believe that's right. Error.o is going to be error.cpp. Error.o, and that should all be right. And then the last one is the Tang scanner. Is that right? Sorry, I'm needing to double check my notes. Yes. The scanner dot o. But this is not here. This is the generated directory, and then I don't think anything else. Watch, I'm just gonna scanner, and I really feel like I'm missing something. So I do need one for the parser. And the parser, no. Can I do it this way? Shouldn't have done that. There we go. Okay, so the parser relies on parser, Tang parser dot, is this right? .cpp, and the scanner dot HPP, not JPP, HPP. All right, so and those are both in the, is that right? In the generated? No, the scanner is in the normal include. Okay. Now, I don't think it's going to find everything, so let's go up to our flags. First of all, for our lib objects, we need to I need to learn how to paste that without it doing a new line. But you know what? Oh, that's why. In fact, that should have been error.o. Parser and scanner You say, Corey, why are you stressing out over this so much? I'm actually trying to use the Vim key bindings, but I should probably give up on that at the moment and just get this out. All right. Now, where are we looking for our includes? I think that's a problem at the moment. I need to double check. Yes. Because the dot, like the location.ll location.hh is in that one. Let's find out what we broke, shall we? So AST can't find location.hh. The question is did that get built? What's the generated? That doesn't exist, so it didn't get built. Why doesn't it get built? Okay, so AST let me go back to my, I had it's not necessarily a cheat sheet, but it's rather a thing of this causes this and this causes this. The Bison rule. So AST requires location, which means the Bison rule needs to have run. So it's not that it necessarily requires that. So does error. We can revisit this to see if it needs to, if we need to have a different intermediate rule or something like that. But for right now, if we do this, how will Tang parser get generated? By running the Bison thing, which will also generate. Yeah. And in fact, I'm just gonna change this now. I don't want location.hh. There we go. Okay. So special rule, another special rule. And how will this be? It be by that should work. Okay, boy. Yay. So it's compiling, right? It generated Bison and now tried to compile the AST. We have a few errors, so let's fix this stuff, shall we? I missed a colon, of course. Somebody probably saw that. They're saying, Corey, you missed that. I'm sorry. I've failed you. Include ast.hpp. There we go. And it says it's on line 9. Yep. There's a colon missing. Now what's funny is we can... oh, sorry. Make help. We've got this make watch. And it will... It did that. Now it's going to wait for our changes. It needs a semicolon after the class definition. Fine. I will add those in. And then who didn't put the closing brace? There we go. Okay. Now there we go. So ast.o did fine. Okay, now we're down to error.o. What? Error.hpp. Okay, let's go there. And it says location changes, so should it be Tang location? Well, we got further. Oh, I hate these errors. As I tried to warn you, these are a rat's nest of intertwined things, and if I made just one mistake. So, a closing brace from tangparser.y. Okay, so that's probably where it is. Tangparser.y, which is in Bison. Tangparser.y. And it even gives me a number 34. Okay. Well, I was going for this one, but I guess, but it's in Tang. It's in the generated Tang parser, which is no match to that. So tangparser.y is from this. Of course, I had to. There's a problem with the generated things. Tang underscore parser underscore. So guess what I can't do? Now we're on to Tang scanner. The previous declaration. Tang parser. So it's just because we're reusing that name. So let's call this parse error. I don't think we're using that anywhere. Yet. Okay. Now, symbol class in that does not name a type. Question is, do I just have a stupid spelling mistake? So this is going to be in the include Tang scanner.hpp, right? Line 20. Found it. Symbol type. String does not name a type. Why doesn't string name a type? Anyway, this is in tangparser.y. Unused parameter location. It doesn't like the fact that we're not using it because I've got every single error turned on, and I say interpret all errors as warnings. I don't want to necessarily fix this, but I'm going to do is that how it I didn't think that should have worked. I don't think it did. I don't have an error with that. Okay, that's fine. I can add it to the error class really quickly. Location and then message. Vim include error.hpp. I'm going to switch those around. Evidently, I don't have all of my stuff working just right. All of my fingers. All right, now we're gonna have to go back to that because I put it in the opposite order. Well, I should probably finish. There we go. And now go back to Tang parser down at the bottom and change this to message location. Pound defines. So that's in the scanner. And that's it. It's compiling. It's not doing anything, but it compiles. And now, if we look in build, well, generated, we see the location.hh and the Tang parser stuff. If we go to the objects, of course, we will see all of the objects that are generated. And then if we go to apps, which will later contain actual things where we write like the tests and everything. And I don't know, maybe apps is a bad word. Maybe we should call it bin or something. I don't know. We have our shared object. How big is that? 179K. Okay, interesting. Yeah. So here's what I'm going to do. Off camera, I'm going to add documentation and update. Well, if we look at this is our current thing, and if we say make docs, because I'm in apps, there we go. Doesn't look like much has changed until we go into the classes. We go into the class list. Now we've got all of these, and we can start looking around. Oh, and it's got nice little diagrams for what makes up an error. There's a location that has a begin and end, and each one of those is a position, and it has a file name as well that and also the error has a message that's a string. And so you can just see what it's relying on. I had forgotten about all that, but anyway, or it could go into, there it is. That's what makes up a location. Or the AST node. It just tells you, hey, AST node integer is relying on that. Oh, and it's clickable. That's nice. And we don't even have any stuff for this yet. And you know what? By stuff, I mean we don't have any documentation for that. But if we do make docs-pdf, there we go, and then WSL view docs/latex/refman.pdf. Now we're starting to see something a little better. Uh, oh, wow. There's a lot more. So we haven't even done a lot of the documentation yet, but it's starting. Oh, yeah, it lists the files. I'll give information about them. Includes, of course, all of the information. I don't think they're not clickable in here, but these parts are. Anyway, okay, so it's starting to look like a real project, and we're not even doing anything yet. But I said, by the way, this will, at this moment, it will parse a 3. I know it will, but this has gone on for, I don't know how long the recording is right now. I might fast forward through a few parts, but oh my goodness, it's it's been recording for over 2 hours now. And hopefully now you can see, why did this take me 10 hours just to prepare for it? Because I had to read so much source code and figure out, okay, this has got to be here and there, and this has got to be called before something else. It's long and involved. But you know what? In the end, now we have the scaffolding to build our grammars for the language and to build our regular expressions for the tokens. I'm not going to say that everything else is easy to compare to this, but everything else is significantly easier until we get into functions and some of the other stuff. But the goal for next time, well, I mean, the next video is to actually, okay, we're going to compile the script and run it. Well, I'm hoping we can run it. But again, we'll get the scaffolding in place. And then we'll make sure that we cover our edge cases, like what if it's empty, other stuff. And I don't know, depending on how long it's getting, we might be able to do a simple expression like one number plus another number. We'll see. So, all right. Well, if you've stuck with me this long, huge thanks and congratulations. I know it's a lot of work, a lot of concentration. You probably had to break it up. And but in the end, like I said, I hope you enjoyed it. What all do we have? Obviously the stuff in Flex, obviously the new includes, the new stuff in source, and then in docs, obviously there's a lot of new documentation pages, but, oh, and of course Bison. And then there are existing documentation things that need to be updated. Oh, yeah, I mean, you may notice it has other things like JavaScript files in here, and the reason is because if you want to do something like, let's search for, something, AST, why not? You notice it works. It's because all of this is precompiled so that it's served statically. Yeah. And then you can jump to whatever you need to. Anyway. I'm like a kid with a new toy. What can I say? We don't have any type defs yet. We will. Oh, that's cool. I didn't know that it gave the variables. We haven't documented them in the others yet, but we will. Anyway, alrighty. Have a great day, and hope you learned something. All right? Bye.